In this video, I'm going to show you a coding trick in C that allows us to swap the values of two variables without using a temporary variable. After that, I'll explain the math behind it in terms of how it's working. So the typical way that we swap two variables in C is by using a temporary variable. And here's an example of that. We have x set to 25 and y set to 35, and then we have a temporary variable called temp. And what we do is set temp equal to the old value of x. Then we set x equal to y, and then we set y equal to temp. So we basically stored away that value of x into temp so that we could overwrite x with the current value of y, knowing that we've stored away that old value of x so that we can assign it to y after. So if we save this and run it, we're going to end up with x 35 and y 25. So to do this without a temporary variable, we can use what's called the Xor operator. And the Xor operator is an operator that works at the level of the bits of these two numbers. So I'll show you the code. We'll say x is equal to x XOR y is equal to x XOR y, and then x is equal to x XOR y. So it looks pretty funny, but this will work. If we save this and run it, we'll again end up with x 35 and y 25. So it is performing the swap. So how is it doing this? To understand this, we really need to understand the math behind the Xor operator and what's going on. So ultimately, numbers like 25 and 35 are represented as a binary number in our computer, a sequence of zeros and ones. And each digit in a binary number is called a bit. Now, Xor is called a bitwise operator because it's going to work at the level of the individual bits in our numbers. So Xor is going to go through and it's going to work on each pair of digits, each pair of bits at the same index in our two numbers. So first, it would work with the 1 and 1 at the first index in these numbers. Then it would work with the 0 and the 1 in the second index of our numbers, and then the 0 and the 0 at the third index in our numbers, and so on, through the entire number. And the way Xor works is if we have a 1 and a 1, the result is 0. If we have a 1 and a 0, the result is 1. If we have a 0 and a 1, the result is 1. And if we have a 0 and a 0, the result is 0. So if we take 25 and 35, and we apply this bitwise Xor operator, we have 1 and 1 in the first digit results in a 0. A 0 and a 1 in the second digit results in a 1. A 0 and a 0 results in a 0. A 1 and a 0 results in a 1, and so on. So that's how Xor works. So how does applying Xor like this end up swapping the values of x and y? Let's break the algorithm down into 3 steps. We'll say step 1, step 2, step 3. And let's also keep in mind that the x bits might change in step 1 because the result of x XOR y is assigned to x. The y bits might change in step 2 because the result of x XOR y is stored into y. And the x bits might change in step 3 because, again, the result of x XOR y is stored into x. And knowing that the Xor operator works at the level of individual bits, there's really only 4 possibilities. The 4 possibilities are that the x bit is 0 and the y bit is 0. Or that the x bit is 1 and the y bit is 1. Or that the x bit is 0 and the y bit is 1. Or that the x bit is 1 and the y bit is 0. And what we want to show is for any one of these 4 possibilities, after applying this algorithm here, we're going to end up with the x bit and y bit swapped. Because if that happens across all the bits in x and y, then we can be sure the two values will have swapped. So we'll take this approach of looking at what happens with individual pairs of bits in x and y at the same index. So if x is 0 at one index and y0 at another index, it's pretty simple. If we just keep on XORing zeros like this, it'll just remain 0 the whole way through. That bit will be 0 again after the first step. When we do 0 XOR 0, the resultant X will be 0 again, and so on with step 2 and step 3. So nothing too exciting there. It gets a bit exciting when the X bit is 1 and the Y bit is 1. So if the X bit is 1 and the Y bit is 1, and we do an XOR of X and Y, the result is 0, and that gets stored into X, right? Because 1 XOR 1, as we set up here, results in 0. And so that's going to be stored into X there, right? So we do X XOR Y, and we have 1 XOR 1, and then X is going to be 0. And now we do X XOR Y, and we have 0 XOR 1, and we store the result into Y, and 0 XOR 1 is going to be 1. So after storing the result into Y, we're left with Y having 1 in that bit. And then we do X XOR Y, which is going to be 0 and 1 now. And we store the result into X. And so 0 XOR 1 is going to be 1. We store that result into X, and now we have 1 in X and 1 in Y. And so ultimately, we ended up back with 1 and 1, which is what we wanted, because it was 1 and 1 to begin with. Let's look at the next two possibilities. This is where things get a little more interesting. So let's say the X bit was 0 and the Y bit was 1. Now if we apply XOR, X XOR Y, 0 and 1 gives us 1. And that gets stored into X, right? So now after step 1, X now has 1. Then we do 1 XOR 1, and the result gets stored into Y. 1 XOR 1 is 0, and now we have X is 1, but Y is 0. And then again, we do X XOR Y, and we have 1 and 0, and 1 XOR 0 is 1, and we store that result into X. And so X ends up as 1. And so now, despite the fact that X was 0 at the start and Y was 1 at the start, in terms of the bit we're looking at, now it's flipped. And X is set to 1 and Y is set to 0. So there's one more possibility. And that's the possibility that the X bit was 1 and the Y bit was 0. So looking at this, again, we're going to do X XOR Y. So we get 1 XOR 0. The result is 1. And we store that into X. And so we end up with X being 1. Then we do, again, X XOR Y. So 1 XOR 0. The result is 1. And we're going to store that into Y. And so we end up with Y being set to 1. And then in step 3, we do X XOR Y. And we're left with 1 XOR 1. And that's going to be a result of 0. And that's going to be stored into X. And we're left with X being 0. And this should be Y is still 1, because Y was not changed during that last step. And so we flipped X and Y again. So X was 1, Y was 0. We end up with X being 0 and Y being 1. So that's how the coding trick works at the level of the bits. And I know that's a lengthy explanation, but I did want to explain it. I find most videos and other content out there doesn't actually explain how the trick works. And so that's how we can swap the values of two variables without a temporary variable in C. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.